we have discussed about this two different processes. One is the late alone process or field process, where you just keep the vinegar, ethanol or spoiled wine in a container or in a tank, and then aerobic bacteria, mostly acetobacter. Acetobacter will actually oxidize this vinegar. So typically for vinegar production, we rely on acetobacter oxidants. So typically rely on different strains of acetobacter, but one of the common species is acetobacter oxidans, which will oxidize the alcohol, and then it will produce the vinegar. And when you talk about culture preparations, it is in the similar manner the way we preserve any other culture or bacterial culture. In the similar manner, this culture is preserved, and mostly when you try to start the subculturing, you keep a stock of the culture in agar slant. So essentially, you have this agar slant in the test tube, and there for initial growth, you will use say mixture of dextrose, ethanol, acetic acid, peptone. So this broth and agar will actually have dextrose, ethanol,
Sir, you something on the board?
yes.
I guess there was some lag. Now it's visible.
Okay.
No, sir, it is fine.
Okay. Thank you. Thank you. Acetic acid, and also you'll have peptone. So if you need to provide other nitrogen sources, then you can actually use little bit of yeast extract and agar. So agar is your solidifying agent, and in the broth you have this dextrose, ethanol, acetic acid, peptone, and yeast extract. Yeast extract is actually providing nitrogen source. So if you want to replace this synthetic media with a complex substrate, then you can use simple tomato juice. So they call tomato juice agar. So this slant, you will have the slant along with this broth and agar, and there you will just grow this acetobacter oxidants, and their optimal temperature is about 30 degrees centigrade. And after growing them in the slant, so after using a loop, if you just take a loop full of culture and then try to spread it on the slant and then wait for incubation. So after 2 to 3 days of incubation at 30 degrees centigrade, you will get substantial growth. Then from there you can just transfer it to the sec flask, and then you move to a larger sec flask, and then you can have submerged fermenter for growing this culture. Now you have to make sure that the subculturing should be done in such a way that you get the cell viability, because one option is to grow them and then freeze them or keeping them at low temperature for long-term preservation. But when you try to keep them for long-term preservation in fridge, like if you want to maintain preservation or keeping them in the fridge by for longer period at 5 to 10 degrees centigrade temperature, cell viability will decrease. So if you need to go for long-term preservation, then it is better to lyophilize the culture and then you store the dry lyophilized culture. So industry mostly they prefer to have this live culture where they are sure about the cell viability, and wherever they need to transfer the culture from one country to another country, then they prefer to do it in sending the lyophilized powder culture, because they don't try to send the live culture grown on a slant. And whenever you try to grow the culture in larger flask, like after slant, you will actually transfer the culture to a 250 ml sec flask. Then you'll go for say 2 liter sec flask. Then you'll go for a reactor, a 20 liter, 200 liter. Everywhere in all these sec flasks, you will try to maintain at least 4% volume by volume alcohol concentration, that is ethanol concentration. So if you have really very low alcohol concentration, suppose you this bacteria, they have already utilized all the alcohol, then they will not able to survive, because the competition will start, because they will actually go for starvation, because alcohol is their food. So for any such reactor, they always try to maintain at least as minimum as 0.2% volume by volume alcohol. Otherwise, the bacteria which is responsible for production of acetic acid will die. And this, if I think if I just write down the equation, then you will see from 1 mole ethanol, you will get 1 mole acetic acid. Now, this 0.2% ethanol is kept in the reactor to maintain the cell viability. And also, after the conversion from 4 to 0.2% ethanol, you will get almost 12% acetic acid or vinegar. Because acetic acid or vinegar, they are sometimes we actually say that acetic acid means vinegar. That is actually not true, because in vinegar you have acetic acid as the major constituent. Along with acetic acid, it is better to write acetic acid. So vinegar will have acetic acid, and along with acetic acid we have water and also some organic constituents which will come out from the reactor system to the vinegar, and that will also give a different kind of flavor or taste. So if you chemically synthesize vinegar, there you can actually have really water acetic acid mixture, whereas the biologically transformed vinegar process or biologically transformed process where you try to get vinegar from spoiled wine, there or maybe spoiled alcohol, there you will get acetic acid, different other alcohols, and also some aromatic compounds and water. And when we'll discuss about type of vinegar, there actually you'll get to see the sources we use for production of vinegar, and based on the sources, you'll also get different other ingredients or different other component present in the vinegar. Now, in industrial production process, first you grow the culture so you can get substantial amount of inoculum, and everywhere, wherever you have done this submerged culturing, there you try to maintain at least 4%. So it is less than 5% alcohol, because more than 5% alcohol is also not good for the bacteria. So you try to maintain around 4% ethanol concentration, and also make sure that the fresh or additional feed is supplied to the system wherever the concentration is reduced to 0.2%. And in modern fermenter, they have sensor to sense this concentration. So whenever they will sense this concentration, automatically feeding tank will open and then fresh feed will get added to the system to maintain desired concentration of alcohol. Whereas in the old fermenter or in small scale fermenter system, they are still manually check the concentration and they start the new batch. So it is running in a batch mode. So they start the new batch by withdrawing the liquid from or product from the system and add fresh substrate. So it is not completely as in batch mode because you are not finishing and then going for a new product. So you can say the operation in a stable ethanol acidic vinegar production unit, they go for fed batch mode. So they withdraw certain amount of product and then also replenish by adding fresh substrate. So we have mentioned about old processes where you get let alone process or field process where you don't do anything, just keep the alcohol in the container or in a tank and the bacteria will work on this system. You're not supplying any oxygen also. So it is open tank. So air will come from the top and then they will get diffused to the liquid and it will slowly oxidize vinegar in presence of the acidobacter oxidants. Now, this is inherently slow because you are not adding any external aeration. So, little bit quicker process is having a system where either you can supply air or you can actually create the system in such a way that even if you don't have active supply of air, you will have passive supply. Passive supply means suppose you have a system where this liquid is kept in a specific manner on a tank and you also have a false bottom. False bottom means a perforated plate and the perforated plate and the side walls are kept in such a way that whatever liquid is coming to through this perforated plate to the bottom section, that will just follow a different pipeline and above the liquid you have some sort of option to so you have some holes on the reactor. So air will just pass through this hole due to natural convection and it will try to aerate the liquid. So this extra holes in the reactor can actually increase the oxygen supply and that can make the process a little bit quicker. And in advanced system, you can actually have air supply line. So instead of having holes on the reactor wall, you can have aerator. So you will have a spurger at the bottom and the spurger will actually uh, through the compressor will supply the compressed air to the spurger and then will aerate the liquid at a desired level and you can actually improve the conversion so you can get much faster conversion. And typically these reactors are known as generator. For acetic acid or vinegar production, these reactors are known as generator. And this generator can have two different configurations because in earlier class I mentioned if you need to increase the conversion rate, then one option is to, because everywhere we say Rx equal to mu into X. So rate is growth rate is already defined because you are just providing certain amount of the substrate. You are not having any variation. So Kx is same. Substrate affinity will be constant value. Will have constant value. Similarly, mu max will also have constant value. So mu is almost constant there. Only thing is that you can, if you just increase the biomass concentration, then you can get faster rate. So to increase biomass concentration, you have two options. One is use of packed bed reactor. You have some packing material inside the reactor and the biofilm will grow on the inner surface of the outer surface of the packing material. So in a given volume, you can get substantial amount of biomass. Another option is just have the biomass as in a slurry form in a reactor where you have stirrer also. So it will not allow the biomass to settle. So mechanically, you can agitate and then have little bit higher concentration of liquid, it is it is actually very different from the earlier design, because earlier design it is a simple tank without having any stirrer. So there is always a tendency of higher biomass will actually get settled, so they will go out of the system and they will have very minimal interaction with the liquid. Whereas here, forcefully you are keeping them suspended in liquid, so we'll have better transport of nutrients, as well as the transfer resistance will be minimal. Then you can get much faster production. So traditionally, this generators are termed as, so we have talked about late alone process. Then the same thing is fill processes. It is also known as fill process. Then you have generator, and in generator you have two types. One is trickling generators, and second is submerged culture. So trickling generators are actually the traditional, sorry, reactor. They are very large cylindrical reactors, and then they will have a perforated plate, or and this plate is also made of, it is a wooden perforated plate. You will have support to hold this plate, and the inside wall would be made of stainless steel, or you can have wooden fermenter, and this entire fermenter will be filled with either wood shavings and typically they use beech wood shavings, because when you use different kind of woods, different aroma and color will be contributed by the wood, because different organic compound present in the wood will also get leached to the liquid, and that will give different aroma as well as color of the vinegar. But beech wood is well known because it doesn't give a objectionable smell or objectionable color to the final product. So curled beechwood shavings are used, and at the bottom you will have the collection of the liquid, and just above the liquid you can have either some holes for creation of natural ventilation, or you can have a sparger to supply air, to air it. So air will actually move up, and this entire thing will actually have this curled wood shavings. So obviously when you talk about mechanical strength, wood shavings will not have too much of mechanical strength. So they will be very light in weight also. And this bed, as these wood shavings are very cheap, so due course of time, they will also lose their mechanical strength. So when they will become very wet, and as they are present in the acidic environment for longer period, they will also try to get compressed. So if you feel that this entire bed is getting collapsed, then you just take out the wood saving and replenish with the fresh wood saving. So wood savings are very cheap. That's why maintenance of this bed is also very easy and economical. And on the top, you have a distributor for this distributor will actually sprinkle the feed. So you have feed solution having minimum, which at least you have 44% ethanol. Typically, this feed line will also be connected with a recirculation line. So some amount of liquid will be collected from the same line, and the remaining portion will get recycled back. So you will get more contact. So continuously recycling will be done, which will actually ensure higher conversion. And at the end, from the bottom, we'll try to get around 12% acetic acid and ethanol concentration. So this feeding is intermittent feeding. You're not continuously at the feed. First you charge with the fresh feed, then you just keep on recycling the water. So when you try to recycle the water, you have actually kept this fresh feed line close, and using a pump, you are just recycling the water. So water will trickle down the bed and air will also go up. So they will have good interaction, and the acetobacter oxidants will create the biofilm on the surface, and it will actually convert the ethanol to acetic acid in this trickling bed reactor. So this is this entire system works on the intertrickling generator system is actually dependent on the biofilm grown on the surface of the wood savings. So it is very similar to your typical trickling filter you get in wastewater treatment plant, and it is a packed bed reactor. Now in submerged culture, you actually get much higher productivity because the transport resistance are much lower. So typically in trickling bed, this interaction is happening because of countercurrent movement of liquid and air, and bacteria is actually static. Bacteria is not moving. Whereas in the other process where you have submerged culture process, liquid and bacteria, all the elements, so the liquid, bacteria, as well as air, they are continuously interacting and they're all mobile. So you are not having any stationary system here. So chance of interaction is much more here in submerged culture. That's why you get much higher conversion. So when you talk about production rate, obviously this trickling generator will have little bit lower production rate compared to your submerged generator. And here, this bacteria is quite sensitive to temperature. So if the temperature goes beyond 38 degree or 40 degree, bacteria will not be able to survive. So in this large trickling generator, it is not very easy to maintain good temperature distribution. And the temperature distribution is mostly controlled by the air temperature. So at the bottom, the temperature, because this process will generate energy also. The production of acetic acid will also generate heat. So whenever you try to reduce the temperature, you use relatively colder air. So when you supply the cold air from the bottom, at the bottom you will get say around 35 degrees centigrade, and at the top temperature of the generator will be around 29 degrees centigrade. So you try to maintain the temperature close to 30 degree because that is the optimal temperature for this bacteria. And whenever you have significant reduction of volume due to the poor mechanical strength of wood shaving, and when they start collapsing down, then you just replenish the wood bed by fresh wood shaving, and at least you try to maintain 0.2% unconverted or residual uh, ethanol. And when you do the aeration from the top section, you have vents to allow the excess air to go out, so it will not build up any pressure inside the reactor. So at the top, you just use a DO probe to monitor DO concentration. So for this kind of system, typically 12% DO in the excess gas is considered as the reasonable amount of oxygen you're supplying. So if you get 12% DO in the exhaust gas, that means your generator is actually getting sufficient amount of oxygen for this conversion of ethanol to alcohol. And one generator can be used for almost 20 years. So even if you don't spend too much of money to make this particular construction, but still the wooden generator can be used for about 20 years. And when you have higher acidity, suppose you are getting higher acidity in the system or lower acidity, then actually it get formation of different other organism or growth of different other organism which can spoil the vinegar. So if you have really very low concentration, like less than 10% acetic acid in the bed, then other organism will grow and they will spoil the vinegar. If you have higher concentration of acetic acid, that can also create problem with the bacteria responsible for vinegar production. So typically, this maximum 14 to 15% of acetic acid can be obtained from this kind of system. So if you want to have 20% acetic acid or 30% acetic acid, then you have to go for distillation. So in submerged reactor or generator, they're also sometimes called as acetator, because in generator you are just producing acetate or acetic acid, so they're called as acetate generator or acetate. Now, with advantage of the submerged system is you have much higher control on the process, because you can use sophisticated control units to manipulate or to change the speed of the stirrer. You can have better control on oxygen supply. You can have better control on addition or removal of material from the system. So this submerged culture systems are a little bit more expensive because the capex or capital cost is a little bit higher. And advantage of the system is you get much better, much quicker production, and also much better control on the production. And temperature control is also much easier because you can have heating jacket or cooling jacket to maintain desired temperature for the reactor. And other conditions like alcohol concentration. So there also feed should have whatever raw material you use. There you should have at least 2% alcohol, and also the final solution should not have less than 0.2% of alcohol. Only difference is it is much more, the control is much more intense, and you can have much higher conversion rate. So you can have higher productivity in this system, and also you don't need, even if you try to compare the volume, then essentially to produce same amount of acetic acid, you will need much lower volume of reactor. So the reactor footprint will have significant size reduction when you use this submerged system. So advantages, if you try to count the advantages of the submerged system, so submerged versus trickling. Acetator. Here, one is actually space. So to produce same amount of vinegar, submerge will require 1/6 less amount of space. Productivity is higher. You get higher efficiency. And also the yield will be higher by almost 5 to 8%. And another advantage is it is actually advantage of the reactor design, because here in trickling filter, if you need to go for production of, say, in industry, you try to produce white vinegar, then you realize no, it is better to go for malt vinegar. Maybe another batch I can produce apple cider vinegar. So in this generator trickling filter, it is not easy to switch from one type to another type of vinegar. Whereas the submerged culture system, you just remove entire things from the system, from the reactor, wash it with normal water, and then sterilize it using steam, and then you go for another type of vinegar production. So switch from one to another type of vinegar is much easier. And also you have better control, so you can have better automatic control. So these are the advantage of submerged system over trickling generator. Now trickling generator, these are all traditional trickling acetator, they are traditional reactor, and in current bioprocess industry they don't get that much uh, attraction, because not only this reason of different advantages of submerged process, they also have issue with vinegar spoilage, because the trickling system or trickling acetator has a very poor uh, controlling ability. So when you try to grow the organism, you have very poor control on maintaining sterility. Although you are relying on one type of organism, but in trickling filter or trickling acetator or generator, we have really very low control over maintaining the sterility in the system. So when you use the wine or spoiled wine, or even if you use try to produce the cider vinegar, means from different fruit juice, then nutrients are already present in this system. Means wine as well as cider will have nutrients. But if you need to produce acetic acid from pure alcohol, like pure alcohol, water, acetic acid mixture, then you need to add different nutrient supplements. And you can have corn sugar, ammonium phosphate, magnesium sulfate, potassium citrate, and this all this and yeast extract to provide nitrogen and vitamins. So all this material can be supplied additionally if you use different kind of substrate. And most of the cases, whether it is submerged or your packed bed reactor, we use mostly spoiled wine or your different fruit juice to get cider vinegar or wine vinegar. Now, when you use normal alcohol, means pure alcohol, ethanol, there you need to add different additives. So these additives can actually trigger to other organism to grow in the system. And as submerged culture system has better control on over fermentation, that means you can maintain reasonable amount of sterility in the reactor system. So even if you use different nutrients and other complex substrates, you can still maintain pure culture environment because you have better control on sterility or better control on sterilizing the reactor. Whereas in packed bed system or the trickling acetator, it is very much possible in the environment, the organism present in the environment can also start growing inside the bed, and then they can create problem with the final product. So the common problem we see in the trickling filter presence of one of the nematode. And this name of the nematode is Angulula aceti.
So your screen sharing has stopped, I guess.
I guess it's visible.
Okay, I guess I'll have to rejoin.
Achha. Is it visible now?
Not really. So,
Yeah,
so maybe you can
it's
continue.
visible.
Oh, mhm. So the presence of nematode is actually not very good because they will create a problem with the flavor as well as the taste of the vinegar, because this organism, they will grow in the same environment. They're also known as vinegar eel. And this vinegar eel will utilize the substrate, and also they uh, eat some of the bacteria also, and then they'll produce the excreta that can also create problem with the quality of the vinegar. And during their death, the putrefaction of the dead organism can also create problem of a different kind of bad odor. So if you get a foul smell, then definitely that will reduce the market value of the vinegar. So vinegar ill is one of the common problem with trickling acetater. And earlier, people used to think that presence of vinegar ill is very much essential to get good quality vinegar. So then later they realized that this particular organism, this nematode, is actually creating problem rather than helping the production. So different insect will also try to grow because it is an open system. On the top, even if you have a cover, but still, as we are not maintaining too much of sterility in the reactor system, through the vent, different insect can also get into the bed, and they can also create problem with the production process. So, and they can actually reduce the quality of the vinegar. So for this kind of system, generally, frequent pasteurization or frequent steaming of the bed would be required to kill this nematode. So one option is to just sterilize the entire uh, trickling filter with steam to eliminate the eel and also this vinegar eel and also different insects. But frequent sterilization will also reduce the shelf life of this system. So obviously, if you try to use the generator for longer period, then you should not have very frequent sterilization because heat sterilization will also reduce the mechanical strength. So you have to change the mat very frequently. And another problem with this system is presence of different mines. They're also known as vinegar mines. So vinegar mines they will also try to spoil the vinegar taste, and to eliminate them again you have to rely on the steaming operation only. So you have to sterilize by using really superheated steam. So frequent sterilization is required to get rid of them. And most common thing is formation of biofilm layer. So I mentioned whenever you have less acetic acid concentration, like less than 10%, then you will have formation of or growth of overgrowth of Acidobacter xylenum. So it is one of the biggest problems. So obviously these are problem which you need to address by steaming the system. But one of the biggest problem with this trickling filter is formation or growth of overgrowth of Acetobacter xylenum. So Acetobacter xylenum can overgrow the Acetobacter oxidans if you have very low concentration of acetic acid. So if you maintain more than 10% acetic acid, this 10% higher, over 10% acetic acid concentration will actually inhibit Acidobacter xylenum. Problem with growth of Acidobacter xylenum is that it will create really a slimy mat on the surface of the inert material, and it will not allow the actual Acidobacter or useful Acidobacter oxidants to interact with the liquid. So you will have a slime formation on the inter bed, and that will also create blockage in the bed. So you will have flooding because you will not get good channeling in the packed bed reactor system. So if you have less than 10% acetic acid present in the system, it will promote growth of Acidobacter xylenum, and that will block the inter reactor bed. So this is also one of the common problem we face in trickling acetator. And fourth problem, it's common for both though, fourth problem is excess amount of phosphate presence of excess amount of phosphate in the raw material can create problem with the turbidity, because you will have production of turbid vinegar, and that is not very lucrative. So you will have significant reduction in the quality if you have excess amount of phosphate. Same thing is true with water. So if you use a lot of hard water, because you are having only 12% acetic acid in the final product, and remaining portion will have significant amount will have actually compensated by the water. So if you get 80% water and that water is having a different kind of quality, then that will also have impact on the quality of the vinegar. So PO4, excess amount of phosphate, water quality or water hardness will have effect on vinegar quality. Quality in both, means in both the system, trickling acetator as well as your submerged acetator. So you have to make sure that excess amount of PO4 should not be there in the substrate or in the food supplement, and the water you are using, that should not be that should be of good quality. It should not have too much of hardness. So that will also create hazy vinegar, or you can say turbid vinegar. So production of vinegar is mostly done in these two reactor system, and current practice is to use the submerged system to get all the advantages and to have means to have less problem associated with these three different issues. So if you use your submerged system, then you can actually get rid of this problem with other insect and other organisms present in the reactor system. So Acidobacter xylinum will not grow because you have beta control. Presence of nematode as well as vinegar mites will not be there. So all the problem with other organism will not be there if you use a submerged reactor system. Now, when you talk about the type of vinegar, there you can get 4 or 5 types of different vinegar based on the substrate you use. So one is white distilled vinegar. So you can actually produce that vinegar at relatively higher concentration, and mostly you produce it from alcohol. So instead of using spoiled wine, you can just use the distilled ethanol, and then from there you can actually get vinegar produced, and then it will be much more clearer. So you will get almost transparent white distilled vinegar. You can get cider vinegar, which is mostly made from fermented juice, and apple cider vinegar is one of the common vinegar, cider vinegar you can get, where apple juice will have almost 10%, 10 to 12% soluble solid, and that will produce substantial amount of vinegar. So you can have clear, because even cider vinegar also you can have very clear vinegar of a different color, because the type of fruit juice you'll use, that will impart the color in the vinegar. You can get turbid cider vinegar, you can get clear cider vinegar, depending upon the final filtration process you're using. So in some cases, they deliberately keep some solids present in the system. So apple cider vinegar, if you buy from the market, you will actually find a transparent, or you can say clear vinegar of a specific color, or you can get little bit turbid vinegar of similar color. So depending upon the final process you use to remove the solid, to get the color as well as turbidity in the final cider vinegar. Similarly, wine vinegar also you can, and that is more common. Wine vinegar, if you just use spoiled wine to produce this vinegar, and also you can have malt vinegar. So you can get the malt mash. Generally, we use in the beer production. Same in the similar manner, you can get the malt mash, and then try to do alcoholic and acetous fermentation. So first you take the malt mash, do alcohol fermentation, and then you do this acetous fermentation. Whereas the other process, cider vinegar or this wine vinegar, cider vinegar is also following similar kind of uh, process, because first you get the fruit juice, then you just do fermentation to get ethanol, and then you just oxidize the ethanol to acetic acid. Malt vinegar is also, malt is having the carbohydrate, and it will get converted to ethanol during first level of fermentation, and then you do another oxidation using acidoxide oxidants to produce the acetic acid. Whereas distilled vinegar, you just use alcohol. Similarly, whereas for wine vinegar, you are also using spoiled alcohol, spoiled wine. So malt vinegar as well as cider vinegar are produced in a similar manner. Whereas wine vinegar and distilled vinegar, your raw material is actually alcohol. So it is one-step fermentation. Whereas for malt vinegar and cider vinegar, you follow two-step fermentation. First alcoholic fermentation, then acetous fermentation. So malt, we are just using ethanol. Whereas malt or cider vinegar, you are actually first doing the alcoholic fermentation, and then acetous fermentation. And then you do all other processes, like if you need to remove the solid, if you need to remove the bacteria, then you do filtration, then centrifugation, filtration, and clarification. And if you need to up concentrate the vinegar, then you can do by freezing process or by um, distillation. Now the bottling is also another issue, because you don't, mostly if you have high concentration of acid, you prefer to bottle them in glass bottle. So most of the cases, uh, food grade vinegars are actually stored in glass bottle. Whereas if you need to use vinegar for cleaning, which is synthesized chemically, that can be stored in plastic bottle. But preferably, this vinegar is stored in glass bottle. So this is all about vinegar. If you have any question on this, then I'm happy to answer that. And then the next class we'll discuss about some acid production.
It's clear.
Okay.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Okay. Is there any 2020 student here or no? I doubt.
Yes, sir. I'm there.
Acha. Okay, so 2020 students, if you please inform all your batchmates to um, come at least, I think 318. Check once. I have already sent the email to one of your friends.
It's 318, right, sir?
Just a second. Just a second. I have sent a mail to one of your friends yesterday. Just. Mm, So we'll have the exam on Monday between 12:30. It will start at 12:30, so 12:30 to 1:30, and they have scheduled it at. It will be at LH 308, not 318. It will be 308.
Okay, sir. Got it.
So maybe if you please just share that information with all your friends. So they should come by latest by 12:15. So we can start the exam at 12:30 and we'll finish it by 1:30. So it will be day after tomorrow at LH 308.
Okay, sir. And the format for the paper would be the same as the.
Uh, you need not bring any laptop or any notebook. We'll provide you the answer script and question also will provide. So it could be multiple choice question. It could be of your fill in the blanks type of questions also. So
Okay, sir.
you need to bring
And
any.
sir,
You need to bring any electronic gadgets.
right, got it, sir. And the syllabus would be in the minor one or like
Yes, yes,
separate?
yes, 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 yes.
Fine. Sir, can you share the list of all the 2020 students in case I missed someone because I might not know all of them personally.
Mm, 1 second.